Oh, I needed to hand these. Sorry. Okay, so special right triangles. We're going back to geometry. Okay, back to geometry. Do we remember oops, I forgot to get those off. Shh, don't look at those. The relationships for our special right triangles. Do we remember those from geometry? We have two special right triangles. Do you agree that a 30, 60, 90 and a 30, 60, 90 are the same triangle? Do you see that this one is just laying on the long leg? This one is laying on the short leg. So the orientation is different, but the triangles are the same. Okay. For a 45, 45, 90 right triangle, we are going to be looking at if it's in the unit circle, and I'll show you what that means. Unit circle is called a unit circle because the radius is 1. For our special right triangles in the unit circle, the hypotenuse is always going to be the radius. So for all of these, my hypotenuse is going to be 1. Now for a 45, 45, 90, that's an isosceles right triangle, correct? Which means these two sides have to be the same length. Do you agree with that? So I could use Pythagorean theorem to solve for what x is. So I've got 2x squared equals 1. So x squared equals 1/2. So when I take the square root, usually when I'm solving and I take the square root of both sides, I do plus or minus. But because we're talking about the length of that side, we're going to only do positive. So what is the square root of 1? 1. What is the square root of 2? That is right, the square root of 2. Now, does this look familiar? Do we remember that with the special right? If we know the hypotenuse, the leg is the hypotenuse divided by the square root of 2. Do we leave a square root in the denominator? We do not. We are going to rationalize the denominator, which gets me root 2 over 2. So for my special right 45, 45, 90 triangle, the legs are root 2 over 2. Does that sound familiar? Does that number sound familiar from what you've done with unit circle? Now let's look at our 30, 60, 90. I could derive this rule, but it's not worth the time to do that. I'm just going to remind you, for a 30, 60, 90 right triangle, special right triangle, the short leg is half. The short leg is always half the hypotenuse. And then the long leg is the square root of 3 times the short leg. Do those numbers look familiar? Short leg is half the hypotenuse. Long leg is the square root of 3 times the short leg. So now my orientation is different, but knowing that relationship, can I fill in which these two sides are? This one is the 1/2. And then this one is the, stop it, Diego, square root of 3 times the short leg, okay? So with the unit circle, you need to remember 5 numbers. That's it. You have to know 0, 1, 1/2, root 2 over 2, and root 3 over 2. Does anybody have a telephone number memorized? Yeah, that's 7 numbers. So you should be able to memorize 5 numbers. Those are the numbers you need for every single unit circle problem I give you. Those 5 numbers. It's going to come from there. All right. So I have not been able to find a nice unit circle that only gives me the specific angles I'm looking for at a time. I can only get me one that does this. So what I have done is I've kind of whited out the other ones so that we are just looking at the dark ones. So do we see with this one right here that it looks like an XY axis superimposed on my circle with the origin at the center? Do you see that? Okay. So if my circle has a radius of 1, and this is the origin, what would the ordered pair be for that point? If my circle has a radius of 1 and the center of my circle is at the origin, what is this ordered pair? 1, 0. That ordered pair is 1, 0. And would you agree that this is 0 degrees rotation and 0 radians rotation? Okay. And then let's go clear over to the left. What's that ordered pair? Pardon me? -1, 0, right? And what would that rotation be? 180 degrees. What would it be in radians? Pi radians, right? So here, what is this rotation? 90 degrees. Let's do this so I can touch the screen. 90 degrees, or what would that be as a radian? It would be half pi, or pi over 2, correct? And what is that ordered pair? And so down here at the bottom, what is this ordered pair going to be? 0, -1, correct? And what is the rotation? 270 degrees. What would it be in radians? Halfway between 1 and 2 pi, correct? It's going to be 3 pi over 2. And then if I go all the way around, do you agree that this is now, 360 degrees or 2 pi radians? Can I keep going around? So, anyone in here not able to count? Okay, that's good. Only a couple of you. All right. So I start here at 0 and I go 1 pi over 2, 2 pi over 2 reduces to pi, 3 pi over 2, 4 pi over 2. Could I keep counting? 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2, 9 pi over. I just keep counting by pi over 2s, right? Can I count backwards? Negative pi over 2, negative pi, negative 3 pi over 2. The difference is I'm moving clockwise versus counterclockwise, right? Do you see that? Okay. Just counting around by pi over 2s. So now we're going to look at what these ones are. Okay. Does that look like it is halfway between pi over 2 and 0? What would halfway between pi over 2 and 0 be? Yeah. Pi over 4, correct? This is going to be pi over 4. What is halfway between 90 degrees and 0 degrees? Oh, so this is a 45-degree angle down here. And when I draw that down to the x-axis, does that give me a 45, 45, 90 right triangle? Which gives me, oops, let's do it in red. What is my x coordinate when I have a 45, 45, 90 and the hypotenuse is 1? Root 2 over 2 is my x. What is my y? Also root 2 over 2. Do you see that? Does that make sense? And then I can count by this, that's pi over 2. And then when I go here, pi over 4. So I have 1 pi over 4, 2 pi over 4. Doesn't that reduce? This would be 3 pi over 4. So I'm actually rotating 135 degrees, or 3 pi over 4. Do you see that that makes a 45-degree angle right there with the x-axis? Even though I'm rotating 135 degrees, do you see when I draw the triangle to the x-axis, I have a 45, 45, 90? So here at 3 pi over 4 or 135 degrees, what is my ordered pair? Aren't my x and y going to be root 2 over 2, root 2 over 2? It's going to be the same thing, but now I'm in quadrant 2. Is x positive in quadrant 2? No, the x is negative in quadrant 2, but y is positive in quadrant 2, right? So I counted 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. This is going to be 5 pi over 4. What's the ordered pair going to be? Let me give you a hint. It's going to be that, and I just have to figure out the sign. Both of them, S-I-G-N, right? Not S-I-N-E. Both of them are negative in quadrant 3. Do you agree? Okay. So now let's look at this one. Can you tell me the radian measure here and the ordered pair here? Tell your neighbor. Are we seeing the pattern? How many pi over 4? 7 pi over 4. My ordered pair is root 2 over 2 comma root 2 over 2. Which one's negative? The y value is negative. The ordered pair is the same in all 4 quadrants. It's just where is x and y positive or negative? And I'm just counting by pi over 4. So couldn't I go 1 pi over 4, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 pi over 4? What's the ordered pair at 13 pi over 4? Same thing, right? Because I'm just continuing to go around and around and around and around. I could go negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pi over 4. Negative 11 pi over 4. Do we see that? Okay. So now I'm going to actually change the order. I'm going to do this one first. What does this angle look like? What do you think it is? Because we only have one other special right. Here, let me draw it. This looks like here is a 60-degree angle, right? So I've got 60 degrees here. What is 60 degrees in radians? Pi divided by 3, because 180 is 1 pi, right? So 60 is 1/3 of that. And what is this ordered pair? Is X my short leg or my long leg? Teaching freshmen. The short leg. Tell me I'm wrong. Short leg or long leg? Short leg. So the X value is on my 30, 60, 90. This is half of the hypotenuse, and the hypotenuse is 1. And then the Y value is the long leg. What's that going to be? Root 3 over 2, correct? Right? Okay. So I've got 1 pi over 3, 2 pi over 3. What is the degree measure for 2 pi over 3? Bless you. Isn't it 2 60-degree angles? Yeah. Isn't that just 120 degrees? And what is this ordered pair? One half root 3 over 2. Which one's negative? Does that make sense? So I have 1 pi over 3, 2 pi over 3, 3 pi over 3. Is that pi? So what's this one? 4 pi over 3. Okay, fill those two out with your ordered pairs. So what's this one? How many pi over 3s? This was 3 pi over 3, right? So this is 4 pi over 3. And this one is, oh, here's 6. 5 pi over 3. And then what about this one? What's my ordered pair going to look like? Both of them are negative. X is negative. Y is negative. What's this one going to look like? Just the Y is negative. For every reduced pi over 3, if it reduces to a pi over 3, that's my ordered pair. If it reduces to something else, it's covered in the other ones. Do you see that? Okay. What? Okay. Huh? So 1 pi over 3, 2 pi over 3, 3 pi over 3 reduces to pi. That one's covered over here. That one was covered over here. It's covered. If it reduces, it's covered somewhere else. Okay? So then let's look at this one. What orientation does this one look like? What is this angle right here? This one's going to be 30 degrees. So this is 30 degrees. And what would the radian measure of 30 degrees be? $180 divided by 30 is 180 divided by 30, 6. So this is going to be pi over 6. So now let's make our ordered pair. The X value, is that the long leg or the short leg? Which makes it root 3 over 2, right? The Y value, is it that the short leg or the long leg? Does that help seeing it that way? I just converted degrees to radians. Okay. My goal for you is for you to be fluent in radians. Here's my definition of fluent. You are considered fluent in a language if you can speak the language without translating it to the language that you were raised speaking. Do you agree? Okay. I did a study abroad program in Germany, and when I left after 8 weeks, I had finally reached conversationally fluent. I did not translate what they said into English, reply my answer in English, and then translate it back to German. I could hear the German word and knew what they were saying and could reply in German. That's how I want you to be in radians. You should not be converting to degrees, doing the work with degrees, and then converting back. That's not fluent. Calculus must be done in radians, not degrees. Every math class after this is going to be done in radians, not degrees. So we need to be fluent in radians, okay? So I'll show you how to convert them, but we're going to learn the radian measures. So this is 1 pi over 6. Do you agree that this would be 2 pi over 6? What does 2 pi over 6 reduce to? Pi over 3. Isn't that already covered? Isn't this 3 pi over 6? What does that reduce to? Pi over 2. Isn't that already covered? 4 pi over 3. Sorry, 4 pi over 6. 2 pi over 3. 5 pi over 6. Doesn't reduce. This is my next. And what is this ordered pair going to be? Those two numbers. Which one's negative? The x value is negative. See if you can give me this radian measure and this radian measure and the correct ordered pairs. Okay. And let me give you a hint. Talk it over with your neighbor. Is it 7 pi over 6? Is that the first one? Yes. And what's the second one? 11 pi over 6. Right? Because this is 8 pi over 6, which reduces to 4 pi over 3, right? 9 pi over 6, 3 pi over 2. 10 pi over 6, 5 pi over 3. 11 pi over 6 doesn't reduce. Okay? What are the signs? This one is negative, negative. This one is positive, negative. Does that make sense? Okay. Now, the whole reason I'm having you think about the special right triangles is because that's what we're going to use when we use the unit circle. So, would you agree? This shows all of those that we've done there. Would you also agree that if I know all of those, I actually know everything? So if I know that this is, let's do it in green, this is 0, pi over 6, pi over 4, pi over 3, pi over 2, and this is root 3 over 2, 1/2, root 2 over 2, root 2 over 2. This is 1/2, root 3 over 2. This one was 1, 0, and this one is 0, 1. Do I know enough to build the entire unit circle? And all I have to do is count and know where X and Y are positive or negative. Okay? Does that make sense? Again, I haven't taught you how to use it yet, but do you understand that? Okay. How do I use the unit circle? Those ordered pairs, x comma y. The x value is my cosine value. The y value is my sine value. Okay. So here's how I use the unit circle. Okay. Sine of 120 degrees. Every single time I do a unit circle problem, I'm going to do this. Where is 120 degrees? Does it look kind of like that? Right? All right. So the sine is the y value in that triangle. Do I see which special right triangle that is? What is the length of the y value in that triangle? It's a 30, 60, 90, right? As root 3 over 2. Is it positive or negative based on that orientation? The y value. Right? The x value would be what? Negative a half. Okay. So if I asked you what is the cosine of 120 degrees, that's the x value. What would that be? Right? Because I can see that's the short leg of that special right. This is what you need the unit circle for. This is what you're going to be expected to do from here on out in mathematics. If I say, what's the sine of 120 degrees? You better be able to tell me very quickly it's root 3 over 2. Okay? Okay? So let's look at this one. Cosine of 4 pi over 3. Does anybody think you can do it? Let me give you 30 seconds. See if you can do it. I've only given 2 examples. And you should be trying to do it without looking up at the other stuff. All right? So let's count by pi over 3. 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3 is there, correct? Based on my special right triangle, what is the x value in that triangle? A half. And it's negative because it's to the left of the origin, right? Do you see that? Do you see why I spend all that time on the special rights? Because I'm going to do this every time. Even if I don't write it down, you're going to see me, and I'll do it this way so you can follow. You're going to see me go 1, 2, 3, 4 pi over 3 cosine is a half negative. You're going to see me draw this either in my head or in the air. I'm going to visualize it because I don't have this memorized. If you ask me this, I can't just spit it out. I've got to picture my unit circle. And if you can do this every time, there's not a unit circle problem I can throw at you can't do. Okay? What if I asked you for the sine of 8 pi over 3? What if I asked for that one? I'm going to count by pi over 3. 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, 7 pi over 3, 8 pi over 3. What, Jabin? Yeah. Yeah, you can do that. I'm trying to show quickly how to get through it because I don't say pi over 3 on my head every time. I just count 1, 2, 3, 4, 5, 6, 7, 8. Boom, draw the triangle. It's faster than subtraction for me. If subtraction is faster than for you, go ahead. It's totally fine. What is that sine value? I should draw my triangle so that I remember pi over 3 is going to be this one's going to be negative 1/2 again. I need to be better at picking. Nope, sine isn't. Sine isn't. Okay. What if I asked you this one? Cosine of 5 pi over 4. Try that one. I'm making a video. Not the fun time to walk in, is it? Where is 5 pi over 4 going to be located? Quadrant 3. 1, 2, 3, 4, 5 pi over 4. And that's a 45, 45, 90. What is the cosine? Negative. That's how I use the unit circle. Does that make sense? Okay. And the way you're going to get better at it is by just practicing it. There are websites online that you can do unit circle practice and that you can just keep going until you get fast at it. Try this one. Try this one. Let me get you started. What quadrant is negative pi over 6 going to be in?
4.
And it's going to look like that, right? So what is the sign of that one? It's the short leg, isn't it? You see that? Did you get it? Did you get it? This is negative pi over 6. So I'm going to rotate clockwise, right? Because this is the short leg. This is the long leg. I know it based on the orientation. All of my pi over 6s, this is going to be a 30-degree angle. 30 degree is right here. 30 degree is right here. 30 degree is right here. So X is always going to be the longer side. Y is going to be the shorter. If I have a pi over 3, that's 60 degrees. So they're going to be the taller. X is the short leg. Y is the long leg. Because the 60-degree angle is here. So it's all based on these triangles that we drew here. All of these. Tall triangle, tall triangle, tall triangle, short triangle, short triangle, short triangle, isosceles triangle, isosceles triangle. Okay. So what about this one? Tangent. Tangent is opposite by adjacent. The opposite side is the y value. The adjacent side is the x value, which means this is going to be, the y is the sine. So for tangent of pi over 6, here's my pi over 6. The y is 1/2. The x is root 3 over 2. And now I just reduce my fraction. Multiply by a form of 1 to reduce my denominators. And I get 1 over the square root of 3. Do I leave the square root in the denominator? So I'm going to multiply by root 3 over root 3. But I still started with the 1/2 or in root 3/2. These questions will be on the no calculator part of the test, and you are expected to know them exactly. There will be some negative rotations, there will be some positive rotations, and there will be some rotations that are more than one time around. Like I did the 8 pi over 3. Like that one, where you just keep counting until you get to the number. But if you can count around the circle by that unit of measure, you're going to be fine. And then the other stuff I decided not to do. We'll probably hit it later.